Hi. So now we're going to learn about concentration of a mixture of the two of the same type of solution. So when one solution is mixed with another solution, it makes a total solution of a different solution, number three. So in other words, we've been doing powder with liquid to make a milliliter. Now we're going to do liquid with liquid and dilute it or make it stronger or make it a different form. So we're going to make your equation so that there's solution one plus solution two is going to equal solution three. And with your percentages, the higher solution is going to mix with the lowest solution to get something in the middle because it makes sense. I can't have the middle, so I can't have a solution, a total solution be lower percentage um, than what I'm working with, and I can't have it higher than the one that I'm working with as well. So if I have, hold on, make your solution equation, solution one plus solution two equals the total solution. You're going to have a high percentage calculation plus a lower percentage calculation is going to be a combination. Then your total solution is going to be what you're given and this and what you don't know all together. Because altogether, if you have 10 of these and 3 of this, then you'll have 13 of this. But if you have 100 of this and 30 of this, you're going to have 130 of this. So it makes sense that if you have something of one solution and something of another solution, it's the total solutions to get the middle percentage. So what does that mean? Oh, note, a neutral solution, such as water, has 0% concentration. A full strength or pure solution, if it's pure, it's 100%. So if we have something like this, it says find the concentration of resulting solution when 800 milliliters of a 12% acid solution is mixed with 200 milliliters of an 8% acid solution. So here we start with, what I do is I underline it, right? Because if I have 800 milliliters of that, and it's mixed with 200 milliliters of that, then I get some kind of resulting solution. So if I have 800 milliliters of the first thing, I have 800 milliliters of the first thing. And if I have 200 milliliters of the second thing, I have 200 milliliters of the second solution. I make a total of 8 plus 200 is 1,000, and that's where we get the 1,000 milliliters from. Then I have to attach my percent signs, and the 800 gets the 12% attached to it. The 200 gets the 8% attached to it, and the X, that's what we're trying to find, is how much that solution is. And now that the problem is set up, oops, that's not what I wanted to do. Now that the problem is set up, then you can solve using your algebra skills that we learned in chapter 1. So let's solve it. 800 times 12 is 9,600. Plus 200 times 8 is 1,600 equals 1,000x. So I'm going to add those two together, 9,600 plus 1,600. And I get 112, 0, 0 equals 1,000x. And then divide by 1,000. Divide by 1,000. And I get 11.2%. It's going to be a percentage because that's what's missing is a percentage. So I did not change my percentages into numbers like 0.12 and 0.08 because all of them had percentages. So if everything has a percentage attached to it, you do not have to make it into a decimal form in order to solve the problem. So you can pause this, figure it out, and then push record when you're ready. Play. So if I have to find the concentration of resulting solution when 500 milliliters of a 16% acid solution is mixed with 300 milliliters of neutral solution, I'm going to do this. I'm going to say, well, that's one type and that's another type, and I'm looking for the concentration of the third one. So solution 1 plus solution 2 is going to equal solution 3. Solution 1 would be 500 milliliters of a 16% solution. Solution 2 is 300 milliliters of a neutral solution. So remember what we said about that? 300 milliliters neutral would mean it has a 0% acidity level or concentration. Is solution 3. So for here, I have a volume and percent, a volume and percent. Here I need a volume and a percent. So the volume would be 500 plus 300, so it would be 800 milliliters times the percent, which that's what I'm looking for. And then I would solve it. So 500 times 16 is 8,000 plus 300 times 0 would be 0 equals 800x. If I divide by 800, then I find out that x equals 10. So it's going to be a percent because that's what I'm looking for. So x is 10%. Okay. Next one says, how many milliliters of 12% acid solution should be mixed with? $500 milliliters of 20% solution to obtain a 17% solution. So this says how many milliliters of 12% solution should be mixed with 500 of a 20% solution to obtain that solution. So what I do is I go to the word solution and then I can stop my underlining. So my 500 goes with my 20. I don't know what goes with my 17, and I know that something goes with my 12%. So I have solution 1, solution 2, solution 3. So it's asking how many milliliters, x, I don't know that anymore, of a 12% solution, so x times 12, plus 500 milliliters is my volume times my percentage, 20%, is going to give my volume, which now, remember I have to add these two together, x and 500, but I don't know what x is, so I'm going to say x plus 500. That's my volume of my total, and then it's worth 17% solution because it's right here, 17% solution. So here I have 12x plus 500 times 20 is 10 with 1, 2, 3 zeros equals, now I'd have to take the 17 to both that and that. So it's going to be equals 17x plus, and 17 times 500 is 8,500. And then I'm going to do the math. I'm going to bring my 12 over to the other side. So I'm going to subtract 12x. And now I'm also going to subtract 8,500 because I want to bring that over. So if I subtract 12, if I subtract 8,500, I get 1,500 equals, if I subtract 12, I get 5x. And when I divide by 5, I get 300. So now 300 is this part of x, which is my volume. So when I look up here, it's talking about milliliters, so it'd be 300 milliliters. It says in stock there's 400 milliliters of an 11% solution. How many milliliters of a 19% solution should be mixed with it to obtain a 14% solution? So if I look, I have, there's 400 milliliters of 11%. How many milliliters of a 19% should be mixed with it to obtain a, so notice how I underlined it till I saw the word solution. So now I know that there's three things, and it says in stock there are 400 milliliters, so I know that's not the total of 11% solution. how many milliliters, so I don't know, how many milliliters of a 19% solution would I mix to obtain means to equal a 14% solution. But how much is that 14%? Well, we're going to have 400 plus whatever I add there. So this is 400 plus X for my total. Because if X was 3, it'd be 403. If X was 100, it would be 500. So remember, I have a volume and then a percent, a volume and then a percent, a volume and then a percent. This volume happens to be in milliliters, and then the percents in percents. So if I do the math, I do 400 times 11. So I get 4,400 plus 19x equals 14 times 400 is 5,600 plus 14x. I'm going to take my 14 to this side this time because it's smaller than 19. And I'm going to take my 4,400 to this side minus. So I have 5x equals 5,600 minus 4,400, 1,200. And then when I do the math on that, I divide by 5x. Divide by 5, I mean just 5. Divided by 5, and you get 240. So X equals 240. And since we were talking about volume, and the volume was in milliliters, this also is going to be in milliliters. Take these and take them to another page. Okay. So how many milliliters of water, which is a neutral solution, should be mixed with 500 milliliters of dextrose 10% in water to obtain dextrose 5% in water? Well, this is asking how many milliliters of water, which is a neutral solution, should be, that's a solution also, to obtain, and that's a solution also. So I need to obtain, so then this is my equal sign. So the first one I have how many milliliters of water, which is a neutral percent solution, should be mixed with 500 milliliters of a 10% solution, because dextrose 10 in water, this is 10%. This would be the percentage. If it was a 5, it would be a 5. Oh, look, we have a 5 here. If it was a 20, it would be a 20. So it would make, and the volume of that, there's nothing, but I have to add this plus this. So X plus 500 to obtain a 5% solution. And then I can do the math. This cancels because 0 times anything is 0. 500 times that is 5,000. And then if I take my 5 in, I get 5x plus 2,500. And then I'm going to take my 2,500 over. And I get 2,500 equals 5x. And when I divide by 5, I get x equals 500. Since I'm talking about capacity, I'm talking about a milliliter. So it makes sense now if you think about it, because if I add an equal amount of this, then I get half the strength, which is halfway between 10 and 5. Cool. So the last one, how many liters of a neutral solution will be mixed with 1.5 milliliters? So how many of neutral solution? I'm going to stop after the word solution. Should be mixed with this solution to obtain this solution. The word obtain or yield, in this case, it's still you obtain, it's equals. So how many liters of a neutral solution should be mixed with 1.5 liters, well, now we're in liters, of a 15% solution to obtain X plus 1.5 of a 12% solution. So when I do my math, my 0 times anything is 0. My 1.5 times 15 is 22.5. My 12 times x is 12x, plus my 12 times 1.5 is 18. I'm going to bring 18 over, so minus 18. I get 4.5 equals 12x. When I divide by 12, I get 0.375. And that's going to be in liters. If they ask for it in milliliters, remember liters to milliliters, there are 1,000 milliliters equals 1 liter. So I could do 0.375 liters times 1 liter is 1,000 milliliters. When I cancel out my liters, then it'll be left in milliliters. So I can say also it's 375 milliliters. If it doesn't ask, it didn't say how many milliliters, did it? No, it says how many liters. So they're asking for this one. But if it asks for how many milliliters, you would go on and get the milliliters. All right, good luck.